All right, welcome everybody. Thank you so much for joining today. We are going to be talking about thermal efficiency in Rainscreen systems. It's presented today by Linda Potter from Homan and Bernard. Before we start off with today's CEU course, my colleague Helen, Acelab's Director of Architectural Experience, is going to give a quick little intro about Acelab, show you guys how to get in touch with Homan and Bernard on Acelab, as well as get in touch with Acelab's team if you need any support on using the platform after today's webinar. So I'll go ahead and pass it off to Helen, and she'll give a quick little intro, and then we'll go ahead and get started with today's webinar.
Awesome. Thanks, y'all. Welcome. And I am essentially here to make sure y'all have a great experience on the platform. So I'm going to share my screen here. We're going to talk about a few things. One thing to note, a little bit of housekeeping, is that if you indicate interest to learn more, get product literature, maybe have a project in mind, what you will see myself and another teammate do is within your workspace, we will open up a conversation with you and Linda directly so that y'all can interface through the platform. The beauty of this is that that conversation will live on forever. You can also invite teammates into a project where that lives and everyone can kind of see that. So if you're getting information about a lead time or something like that from Linda, maybe someone's out sick, there's a client meeting, everyone has access to that conversation. So do know that what you'll see for that is you're going to see an email come in saying we've started a conversation. Jump back into Acelab, come up to Workspace, and you can converse through there, or you can also respond now directly within your email to Linda about what you might be needing a little bit further. All right, so I'm going to talk about one little fun feature that I want to highlight today in Acelab. We've got a lot of great stuff that's been coming out, and also I wanted to focus on one of those, which is our live chat here. So this is free for architects to use. If you have any questions, maybe you're going through, you have specific ones about, let's say, a Rainscreen, something like that, feel free to reach out to our team. We're here to help. We've been helping with handrails. We've been helping with finding right metal roofs that withstand over 150-mile-per-hour winds. So really, this is a free resource for y'all to get some help on your project. So I'm going to dive into a few of these just quickly. This is our whole group of folks behind the scenes. This chat's answered by myself and another teammate, so no bots. But these are just some examples of how we help people out. So this is one of my more favorite examples. Someone was in a pinch to find aluminum windows with a certain solar heat gain coefficient to be able to send that to her mechanical engineer for modeling. So we were able to send over a nice little recommendation. I'll zoom in here and leave some comments about these various things. So this is one example of what you'll get when you come in and ask for some help. And last but not least, let's talk about how to get in touch with Linda as well. So here at the top in the search bar, you can always put in the manufacturer's name. So I'm going to go ahead and jump in here. And on this page, you'll be able to contact them directly. You can also explore all of their great products that they have available across the different categories. You can then save these to your specific projects, which again is a place for y'all to have collaboration across your entire project team, knowing what you're going to be using for something. And with that, I will pass it on back to Linda. But if any of y'all are interested to learn more about how to set up your Acelab, how to set up projects, get collaboration across the firm, or even a firm library of frequently used products, feel free to schedule a 15-minute demo with me. All right, thanks, y'all.
Awesome. Thank you, Helen. I just went ahead and launched a quick poll. So if you are interested in that 15-minute demo with Helen, feel free to say yes to that poll. We'll reach out to you to coordinate. All right, one last housekeeping item from me. We did ask for AIA numbers upon registration. I will also send over a form in the chat momentarily. So if you're worried you didn't submit your AIA number already, you can request that there along with a certificate. All right. Other than that, just want to encourage folks, please submit questions to the Q&A throughout today's presentation. That'll give us some questions we can answer towards the end of today's webinar. And if we aren't able to get to your question, we'll have a record of it there so we can follow up with you after today's event. Okay, that's it for me. Linda, whenever you're ready, feel free to take it away. You're on mute, but we can see your screen.
You'd think I'd be best by now. Okay, you got the sharing. We're good?
Yes, all good.
All right. Let's get started. Again, my name is Linda Potter. I have worked for Homan and Bernard for now 4 years. Prior to that, I was 15 years in the masonry industry. So my background, as well as H&B's background of 90 years, has been masonry. So when you see this learning education opportunity with Rainscreen walls, it might be something you're not familiar that we do or have done. And so that's part of the education we'll get into today. But just keep that in mind, because I know that there's a lot of different ways we approach learning. This is going to be a Rainscreen wall assembly through the lens of what we've learned in masonry, which are the original Rainscreen walls, and how that can be translated into some of the newer Rainscreen walls that we're doing, and different ways to attach those, etc. So I don't plan to be a building envelope expert, but hopefully you'll learn something out of here that maybe you didn't know before. All right, we'll get started into the actual HSW portion of this seminar. And here's where we're at. We're going to talk about Rainscreen walls, and with a focus on thermal efficiency and what goes into that from the lens we're going to talk about today. And I know there's a lot of different ways you can look at that. So we're going to look at thermal impact, durability, high performance walls, the components, the connections, and really stay dialed in that portion of it, where we talk about just the individual components that go into a Rainscreen design, the thermal impact of that substructure, and what we're thinking about for that connection, engineering those, and some high performance considerations for the air barrier when we're thinking about those thinner panels on a wall. Everything that we are talking about today it comes from industry. It's not just simply my approach on this. It's absorbing the industry information that exists out of there, and the way that I perceive those resources. And so some of this may pique your curiosity, and that's my hope. My hope is you're curious enough to want to dive into something a little bit more for yourself, or to go down a rabbit hole a bit further. We use the brick industry, IMI, RAINA, and the Air Barrier Association for a lot of what drove this conversation today. If you're not familiar, I want to take just a minute to talk about RAINA, because it is a newer association that exists out there. It is, I'm going to call it a sister association to the Air Barrier Association, with a focus of understanding these Rainscreen wall assemblies are becoming more common, and yet there's no code surrounding what that looks like to put these together. And it tends to be kind of the Wild West in terms of what we use as parameters of airspace or insulation depths, and all those individual components and pieces, but how they work together to create a system really doesn't exist. Because like we're saying here, the term Rainscreen doesn't really even occur until 2005. And even then it's in the Canadian Building Code, and it's talking about pressure equalization, not this drainage, flashing, cavity ventilation conversations we're having now when we talk about high performance walls. And so the hope is that as we continue to have the conversation inside RAINA, that some code can be developed, some standard specifications can be developed, some publications can be developed that you can reference, just to make sure that you're thinking about all the different components that you need to think about when putting together these wall assemblies. What happens that we want to avoid is the consequences of not having these standard details that you can point to. We have things like water intrusion, cladding detaching, air barrier failures, the risk of fire and smoke that we're thinking about if we don't put these components together in the right order, or by thinking about the materials that are adjacent of those materials. And what we don't want to have are the horror stories that I'm sure you've all been aware of, or at least read about, where it indicates like this specific job where we had Rainscreen panels on the project. It was just over 10 years old, and all of it had to come off and be reclad because of a moisture infiltration problem that then caused molding from back behind, most likely due to a lack of ventilation or proper drainage. But again, it's really tough to understand what that is when there are no standards of which for you to look at. And so that's part of what we're going to think about, and through that, the lens of today. When we think about basic Rainscreen wall assemblies, and the RAINA definition of this is that you've got an outside cladding layer, a backup structure, and an airspace in between separating the two. Now, of course, you might have insulation and air barriers and all these other things in there. But I'll tell you, it probably looks a lot like a masonry cavity wall, where you've got the brick and the airspace, anchors connecting that brick to the substructure, or to the structure. You've got insulation in there, your air barrier, your backing. The interesting thing here, though, is that it's been years that you've had standard design parameters around your minimum airspaces, how it should be connected. All of those things have been vetted and thought through, and you can reference all these tech notes so that you do it the right way and can avoid some of these problems, provided your contractors follow the rules of installation. But what you don't have is that to look for when we think about these thinner systems. And so what we're going to think about here is walk through those layers and just things that you're going to want to think about if, in fact, maybe you haven't thought about them in this way before. When we look at the cladding layer, really what we want to think about is the fact that it's our first water control layer. And the size of panel, the type of joint, size of joint impacts how well that outer layer sheds the water. Now, even if you have open jointed panels, they're shedding a lot of that water just themselves. However, the concept of your Rainscreen wall is you anticipate that water will get back behind that cladding, just like you would in a brick wall, from however it's going to get in there. There's several different ways water finds its way in a building. That you've got a way for it to get out and stay dry and not cause problems back behind that cladding that you can't see. So you've got a type of material, an option of that joint that impacts that water penetration. You've got combustibility that you're thinking about now in cladding layers with thin systems. You weren't thinking about that combustibility when you're using masonry because it's not combustible. So we've got this new element we're adding here that we have to think about differently. The other thing that's interesting is that if you were using your masonry code or your masonry, how you know to build these brick walls, you've got there's standards here. The masonry unit itself has to be at least 2 5/8 thick in order to be anchored appropriately to the backing, to get the proper embedment of that anchor, to keep that laterally connected so that it doesn't fall off the wall. There's none of those things established today. You can have those as long as you can connect it, as long as the company is fabricating it. Like there's a way to connect it, but there isn't an industry standard that tells us this is how we approach that. We've got this airspace, and we know that that's between those two, outer clear and the backing. It's located behind the cladding for most optimal design. It allows that ventilation and the drainage of water inside of that airspace. The amount of that airflow is going to impact that quality of your ventilation. But the big question then becomes, how wide does that air gap need to be? And we're thinking about a lot of things. You're thinking about, I want the most amount of ventilation, but I want it small enough that I don't have issues with flame spread or combustibility. I want to stop the moisture bridging. But I'm also thinking about fire stopping. There's a lot of things you're thinking about. The interesting thing is like a brick wall has a 1-inch minimum. That's what the code of masonry tells you. But I think a lot of us understand that 1-inch minimum was determined because of the mortar that's getting smushed out behind that wall and dropping down that cavity and potentially getting stuck in there and causing some of this mortar bridging or stopping or thermal transfer, moisture transfer. But then also it's a practical reason of why you typically saw 2 inches of airspace. And that's because as the mason contractor is taking a brick and installing it in the wall, their fingers have to fit back behind there. So is that 1-inch minimum that exists for an airspace in masonry valid for all Rainscreen assemblies, or are there other things we need to think about? Now, this RAINA document here is suggesting that you need at least 3/16 of an inch or greater to stop that bulk moisture from reaching your water barrier. But there's a lot of other things you're thinking about. And I'd urge you to think about, how do you have your wall section set up with the amount of airspace there? And then asking ourselves, why do we choose that? And are we thinking about all the other things that need to go into that conversation as well? When it comes to a backup wall structure, same thing goes here, where we talk about There's a lot of different backup structures that could be acceptable for this. And this is inside of one of the RAINA technical bulletins that kind of just talks about all those different components of different ways that you can set up a Rainscreen wall assembly. If you've got more questions on that backup part, look to that reference as well. We both know that there's more to be thought about though than just those 3 moments, because if you're going to have a cladding, we've got to connect it to the backing, which is kind of funny because there are moments where I've opened plans and details that literally just show the panel floating where it is, and we haven't thought about that connection. And we leave that up to other people to think about or to put together, or the installers. And so this is asking ourselves to say, how can I put this together in a way that's constructible, that is within what I'm looking for my building envelope, and how does that all fit together? But you've got insulation in there oftentimes now, you've got air barriers, vapor barriers. You're thinking about all these other parts of this system as you build your walls. So we'll walk through those individual things. When you're thinking about a cladding attachment, we're thinking about that connection between the panel and the backing. I'm thinking about the capacity that's needed based on the panel that's being chosen. I'm thinking about thermal bridging, combustion. Again, if I'm putting these systems together, I'm thinking about maybe it's not as relevant if you don't have, if you're not triggering NFP 285 due to story heights or types of materials, but it's becoming more of a question of saying, do I have something that's combustible or not? Is something durable? Will it cause corrosion if in fact moisture touches this substructure? The interesting thing about the masonry code is that it dictates that these be metal connections only at this point. And I know that we're thinking about that and we're addressing what else is on the market, but current code tells us those must be metal connections. Right now in the Rainscreen panel industry, there is nothing that dictates what it can or can't be. There's a lot of options for you to choose, or for your contractors to bring to you to say they want to use on this. And so all of this to say, it's part of why we need to really understand what we want to achieve and what exists out there to help us do that. When it comes to the insulation layer, you're thinking about combustion, thermal values, moisture sensitivity, UV resistance. At the end of the day, we want it located tight against that backup for you to get those maximum thermal values. Most of the time in these panel installations, you're going to see a mineral wool type of insulation just because it doesn't burn and it drains. But I've also seen moments where you see other types of insulations there. As long as you're considering all of the things adjacent of that, there's a lot of things that we'll start to see as you bring these parts and pieces together to build your walls. When it comes to the air barrier, it is where I believe we either achieve or miss the energy code, the energy savings that we promise our clients. It's proven by testing and reports and data where up to 40% of that energy cost required to heat and cool a building are consumed due to air leakage. So we can talk about thermal bridging and metal connections versus non-metal connections and true thermal breaks and all these things to minimize that thermal impact. But if we can't get the air barrier right on that building to stop the air leakage, we've not done our due diligence for our owners. They're not going to see that in that change in the energy consumption of that building. And I think depending on where you're at, that holds some big issues for our building owners. And if you're in New York City and now you have a building that's getting monitored and fined potentially if it's using too much energy, we have to slow down and get this air barrier part right. And I'm not doing an air barrier seminar here, but I think it's just important for us to recognize, if we care about thermal efficiency, as the name of this title suggests, we care about air barriers in the building envelope. And if we care about the air barrier, we care about every penetration through that air barrier and how that impacts that building envelope and its air leakage potential. Vapor barriers are things we're always thinking about, which is just controlling that water vapor. And what we found is that vapor diffusion, the balance of wetting versus drying, is something that we can keep ventilated and dry is going to be more thermally efficient. And so we're thinking about all those adjacent materials and whether or not a vapor barrier is needed or where it goes, all of those things, you know, your consultants are figuring out. You've got someone on staff that has a pulse on all of this, and hopefully you vetted that. And then as you're moving forward, all of that is taken into consideration from project to project to keep things simple, because you've thought about it once, you've made the decision based on the types of materials you use and owners and projects that you design that fits your project. But at the end of the day, we've known this in the masonry industry about the efficiency of Rainscreen walls and how they are water resistant and they have better thermal efficiency and they are ventilated and we allow air circulation but when we move that Rainscreen cavity wall scenario to your panels, now you get endless aesthetics, lighter weight buildings, reduced maintenance costs. You get a much faster speed of installation. We have an increase of the amount of trades who can install these claddings. It's optimal for recladding as you look at buildings and ask ourselves, this is a really leaky building. How do I help them get this more thermally efficient without having people leave the building, or you know, as you're doing internal renovations, like how can we fix the outside where we've seen them put insulation on the outside and then reclad over the top. These types of systems work really well for that. At the end of the day, the end of the seminar, my hope is that if you've got some more questions or you're doing a lot of design with this, look back at RAINA. There's a lot of great resources out there. There's a 6-page tech bulletin that is probably more in depth than you're even going to want to know, but it good information for you to really sit down and think about things. There's industry articles, there's webinars, there's symposiums, there's member directories of the people that are involved and helping move this code and these standards forward so that you have some good resources to reference in the future. We're going to move into that thermal impact of those Rainscreen components. And the only way I know how to do this is to reference the data. Data tells a story that our perception or our assumptions either that we can't do otherwise. So little case study here, little story. There was a moment where we were asking ourselves, do masonry anchors impact the thermal efficiency of a building? Right now, ASHRAE still considers the anchors in a masonry wall to be clear field anomalies, and they are small and they are plenty, but they don't impact this overall of a building. So we don't worry about them. We don't have to consider them unless you're dealing with something like passive house, right? But we were curious enough to understand and thought there has to be something to this, especially as insulation increases. So we took it through a scenario. We took a zinc anchor and we spaced it at 8 inches, 16 inches, and 24 inches on center, and put it through a scenario of 1 inch of insulation up to 4 inches of insulation, and asked ourselves, how did it impact the insulation effectiveness? And at 1 inches, let's look at 16 inch because that's typical masonry spacing. You're at 90%. Okay, no big deal. I would say, yeah, let's not worry about it. But look at 4 inches. 4 inches shows us 81%. And I have seen some projects in the Northeast with 8 inches and 9 inches of mineral wool that you can't tell me that fastener isn't impacting the effectiveness of that insulation value, that we don't need to take that into account. So we do know that there's impact there. We do know that anytime you're interrupting insulation in any way, you're going to reduce the overall effective value of that insulation. So what does that mean? Well, we took it and moved it from zinc metal to stainless steel, and also put a nylon coating around that connection to create a true thermal break in addition to stainless steel components. And you can see that we're at 92.6% effective R value at that 4-inch mark and, at the 1-inch mark. So we know that this mattered, but even now, you're probably still saying, well, it's the nylon coating that created that true thermal efficiency increase. It can't possibly be stainless steel, because we don't think about stainless steel in terms of thermal efficiency. We think about it for durability, we think about it for strength, we think about it for corrosion resistance or fire resistance. But that thermal efficiency is something that I don't think that we've ever looked to stainless steel for. But through those analysis, through the data, what we found was stainless steel barrels have 1/3 the thermal conductivity of carbon steel and 1/7 the thermal conductivity of zinc. So we do know that it's more thermally efficient even on its own as a material. So when we think about thermal bridging, we're thinking there's more than just the type of material I want you to think about. I want you to think about the number or amount of penetrations that are done through that building envelope, through that insulation. What's the size of the penetration? Of course, we're thinking about the conductivity of the material. We can't just completely forget about it. We're thinking about the thickness of insulation, the continuity of that insulation. There's a lot of things that go into that. I don't know for certain what went into the RDH cladding and attachment study done here in terms of what was the insulation used to gather this? What was the spacing that these were placed at in order to achieve these results? But I'm sure it's noted somewhere for us if we really wanted to dive down deep this rabbit hole. The reality, though, is that if you look at this chart, you kind of see the continuous girts that have existed that we've seen for a long time are the most offensive when it comes to thermal bridging, and all the way over to the fiberglass, the non-metal components there being the best. Now you can see in here that you've got galvanized steel, aluminum up here, and stainless steel. That kind of shows you that trend towards what we're talking about as well. What we know to be true is there's been some data done recently in understanding stainless steel as a Rainscreen substructure. And inside of that data, we found that the stainless steel connection can retain that effective value of that R value in that insulation up to 96% without having a true thermal breakback behind there. So I think we have this perception, and depending on what project you're designing and your owner requirements, you might need a true thermal break in order to get the U value or R value you're looking to get to meet your energy codes. But this study here and the values that we got back indicate that you don't necessarily have to, because a stainless steel connection is actually pretty thermal efficient. So when we think about stainless steel, as we see this being introduced into the market as a Rainscreen substructure that I don't think we've seen before. We've seen, as you saw in the previous slide, aluminum. We've seen non-metal materials. We've seen lots of different types of girts and materials. What we haven't seen is the stainless steel clip connection concept, where what we know to be true is stainless steel has this capacity beat, where there's an ability, because of its strength and durability, that it could potentially allow you to span 100 inches before you would need another connection, reducing the amount of penetrations through that building envelope. You can put a thermal shim back behind that stainless steel, but it's not necessary. Although I will tell you, in the world we live in today, I think people just feel a little bit more comfortable when you can see something breaking it, especially the inspectors. When we can see that material that breaks those two things, we just feel better about it. So it is something that you can put back there, but just know it's not doing as much there as you think it is. What we're thinking about, though, as we're continuing to put these walls together, is to get your insulation effectiveness, your full amount of thermal value. The whole point of putting it on there is you want to make sure that that's tight against that backing. How are you doing that? And how does that substructure contribute to that happening or not happening. So there are now these substructures out there that allow you to keep that insulation right where it's at, give you that peace of mind that it's there and it's not going to be able to fall off of the wall, and ability to reduce those numbers of penetrations through that insulation is going to really impact that overall effectiveness of that thermal value. So then we have these stainless steel components on the market, and now we're putting aluminum with them. That connection to the backing is stainless steel, which is your thermal transfer part. And then we're taking and we're putting this piece of aluminum into it that's connecting the cladding to the substructure. Why aluminum? Well, because you have to allow for that inward and outward adjustability to get the panel placed level. And most substructures or the backing in general is not straight. And so you have to have a substructure that's going to allow you that adjustability so that your panel is straight. And stainless steel, you cannot just drill through. And so that piece stays aluminum so that you can self-tap through and connect it where you get it to get it level. But we're using a high quality 6000 series aluminum for that corrosion resistance, because we have heard forever, you don't put dissimilar metals together. And it's a big red flag that we want to say stainless and aluminum go together. No, we've heard aluminum and aluminum, stainless and stainless forever. And so because we've seen this introduction to the market of understanding through R&D why we would need to do it this way, there's tests that have been done that aggressive salt testing 1,000 hours between these components to ensure that they're not going to have a corrosion problem should they get wet, because we anticipate them to be in wet environments or at least come into contact with water while it's drying out and ventilating back behind. So if we had to put together this wish list of a Rainscreen support substructure, we'd want something that reduces thermal transfer, if not something totally thermally isolated. You want something that's not interrupting that insulation. You want something reducing that number of fasteners, allowing for potentially slab to slab connections with nothing in the middle of that if your panel can handle that. I don't want to lead you on to say that that's true in every case. Your panel dictates whether or not, but there are panels out there that can allow us that ability to span 100 inches before you need connections that do really well in terms of providing back that number of connections or penetrations being reduced. You've got fully engineered so that you know that you're not going to have the cladding torn off of the wall by wind loads that couldn't keep it on there. That whole engineering concept is something that I think we have to start taking more responsibility for as well as the design community, of saying, what do I have in my spec to ensure that that's getting done? We've got to allow that in and out adjustability, strong enough that it can handle any panels that you want to put on your building, and it can be customized to your project conditions, because we just know that we're pushing the limits of design all the time and asking ourselves, like, how can we get creative with this? And so often the materials that you have play in this black and white space and don't allow you to have fun with them or maneuver them in different unique ways. You want something that you can customize, that you can say, yeah, I can do this radius, I can do this angling and play with that shadowing of these thinner panels while still getting some of that design flair. Let's use that word. There's also stainless steel clips on the market. So instead of, they look different. These ones are kind of, let's look at them in terms of a masonry anchor. They're just the connection, and they come with charts and capacities. And yes, someone's still going to engineer and verify that you've got the right spacing. We use the right fasteners and all those kinds of things, but they're more off the shelf. They're more available, that the contractors can have them in their shop and head out to the job and put them in and move on. They can be vertical or horizontal. Same concept of stainless steel and aluminum working together to create those substructures. Those individual brackets are universal. And what I like about where we're going in the industry for these Rainscreen connections are that we know the power that installer has over whether a project goes well or doesn't. And so as these buildings get more complicated, anywhere we can simplify how this happens is good for everyone. And so this specific bracket was created with the installer in mind, that it's one size fits all. You don't have all these different components or pieces based on horizontal or vertical or inside corner, outside corner, different ones for different backings. This one literally can be used for everything. And I think that that's something that just helps us take some complication out and help it stay simplified. I don't think I have anything else there. Okay, so let's go into engineered systems. Let's talk about why it's important that we think about working with substructures that are engineered to keep you safe. We're going to reference back to masonry because, again, my background. Inside the TMS 402602 masonry code, it talks about stone anchoring. And it says it is not addressed in this code. So same thing for Rainscreen walls. We're going to say, like, there is no code that dictates how this should be done. Everything should be engineered to determine that it is acceptable for this specific project. Same thing goes because delegated design, stainless steel anchors, those are what we've looked to for stone anchors. And a lot of architects don't quite understand this. We get calls every day that say, what's the capacity for your stone anchors for this project? And it comes back to, it depends on all these factors. Same thing goes for your Rainscreen cladding attachments. Why they're engineered, we're thinking about the wind loads, size of panel, your weight of that panel. What's the type of structural backing, the material of that substructure, the thickness of your insulation, the type of your insulation. And I know that these are going to likely be, there's a lot of things that go into those decisions that is more than just the engineering of the substructure. You're thinking about the system too, in terms of NFPA 285 compliance. You're thinking about a lot of other things. I'm thinking about it from just a standpoint of saying, how do we make sure that that cladding is going to stay on the wall and not fall off and not be ripped off and not corrode over time? How does that help, and how does that impact, and what are we thinking about? Well, for sure, we're thinking about the fastener. It's part of that engineering connection. It's not just that the material itself can hold the material, but what about the bracket back into the structure? Is that going to be acceptable, not the outside piece of the cladding attached to the substructure? So that fastener, we're thinking about pull-out values, thermal values, the frequency of them, the size of them, the length of them. All of that goes into an engineered connection that's taking into account your project conditions on that site, as well as the materials that you have put together to create that assembly. Structural things, there's no prescriptive parameters for you to look to for guidance. So that's why they're always going to be an engineered scenario, whether that's happening within your team of designers, or whether you're putting that out as delegated design for the contractors or the installers to figure out all of those components. Either way, we're thinking about the weight of the cladding, the wind, seismic, creep, deflection, impact, blast, the movement of your backup structure. All of those things go into how this is all going to come together in terms of spacing, fasteners, and those connections, which is always going to impact that thermal value as well. But it's going to vary per project. When it comes to delegated design, I think it's great to work with manufacturers that offer that one-stop shop. When we can eliminate more of the game of telephone, more middlemen that can potentially slow down the time it takes to get this done. One thing that we know to be true, no matter where that you live, the timeline of putting these buildings together in terms of design and construction continues to shorten. So anytime that we can help condense that into one space and move that forward in a faster way, I think that that's helpful. Also, without potentially losing some of the translation of what we're trying to achieve from person to person to person if you get a bunch of middlemen. Also, you're going to want to qualify professional engineer. to design that cladding support system. We're thinking about project-specific design, giving you engineering calcs, shop drawings, bracket and rail layouts, part sheets, the fact that it's manufactured in-house with the people that designed it so that we get that full capacity of the system of what's available, and that there's access to technical support. Those are the things I think you're looking for when we start to specify and understand the different materials that exist out there and how that can impact you or help you pull a project through to the end more successfully than maybe others. When it comes to system design, I think it's just really important that we slow down, and we hope that whoever's taking on that engineering does a full review to fully understand what's needed for a Rainscreen system and that design intent that was expected. And is that what you're getting back from the contractor you're asking to do this? Rainscreen systems, they should give you full shop drawings, system layouts, and detailing. We want those project-specific stamped, signed, sealed engineering analysis to verify that, in fact, someone did do an analysis on this job. I don't have a lot of the Rainscreen experience yet of watching those come through from start to finish, from design to installation, but I can reference it back to the stone anchoring side of our business that we've been doing for a really long time. And unfortunately, some of this stuff ends up getting contractors have done a job that did this spacing and anchored in this way, and we assume that that will work on this project over here, and we don't actually do those specific calculations for this job, when in fact we might have completely different parameters and open ourselves up for problems. So ensuring that that actually gets done is going to be necessary for your client's long-term success of that building. Field use installation drawings, component part sheets, all of that's helpful for making sure that these contractors fully understand how the system should go together as they're installing it. The components and hardware manufactured, supplied, all by manufacturers, so that everything is full circle, understood, and part of that system. There is, if you're not aware, a master spec section specific to cladding support systems. It's in Division 7. You can see it here. If you're not using it in your standard spec, you might consider putting it in there. One of the biggest questions we get is, how do I know which substructure to use where? And I think that there's some of that where if you have just something there that you trust and vet, that they can point to of, this is what I meant when I was thinking of a cladding support system. Sure, there's going to be a lot of other options that can get in there. Get as many in there as you can that give you, that you've vetted, that you've thought through, that you feel comfortable with in your firm, and hold those contractors to using those types of systems or working through. I know VE is the biggest word that's out there, and I know that there's concern if we put these in there, we're going to have all this value engineering, and I'm not saying you won't, but I do think that there is a responsibility on our end if we continue for these costs of these buildings to go up in the name of thermal efficiency, that in fact we are giving them something that's thermally efficient, and that building envelope is critical, and you're responsible for your building envelope. The installers of these facades, be it brick or panels, they don't care about the building envelope the way you do, and they don't understand it the way you do. So when they want to bring you something because it's cheapest, we can throw it up faster, we can save you some money, slowing down and asking ourselves how that impacts something that is bigger in the whole grand scheme of things than that connection, I think is the responsible thing to do. When it comes to air barriers, we're going to finish real fast. I don't have a whole lot here, but it is, again, what is most important if we're going to achieve thermal efficiency. And so when we think about these thin panels, we think about open joint materials, you may have to think about your air barriers differently. And I was just in Montana last week, and I kind of thought continuous insulation was common in Montana because of their energy code, except we're starting to understand that we can use ComCheck and we can get our walls to pass without using continuous insulation, which is great. If you can make it happen, there's a lot of ways you can do this now. The problem is if you've got a panel and you don't have continuous insulation, you're adding and you use open jointed Rainscreen panels, like now you've got a barrier that's exposed to more loads and UV. So make sure you've got a barrier that can stand up to that, that's not going to cause you that problem where you're removing panels because your air barrier failed because we didn't think about the air barrier being exposed to these conditions because they've always been hidden and covered by this insulation and these wider thermal valued materials like brick. It's just a different way of thinking about things that we don't want to miss. I'm thinking about longevity of that barrier, the flexibility of it. As your building moves, will your barrier move with it so that you don't end up unintentionally getting cracks and gaps through that air barrier as time goes on with your building? We're always thinking about that permeability of that barrier and all of those as you put these wall sections together. How is all of that coming together to function? One of the things we've learned is that there was, I guess I'll stay here. What we know is that construction timelines might also matter for your air barrier. The temperature, the climates, does it need to be rain ready? Like, do you have lots of rain to where you can't be worried about the rain washing the barrier off the wall if you're using a fluid applied? What's our confidence in its ability to stay continuous, be installed continuously, but then stay continuous as that building is being used and lived in? What's our owner's expectation? Do we have passive house requirements? Do we have other things that are asking us for a more thermally efficient, higher performing building than maybe the next over? There is a new, it's not new, some of you might be even using it, but I would say it's come onto the scene in the last 5 to 7 years stronger than it ever has. And that's seen silicone as that air barrier. It is vapor permeable. It's got that long-term UV resistance, a wide application range, can be done in a single coat, maintains its elasticity. That's what we know about silicone. Silicone is tried, true. We trust it as a construction industry. It moves, it's long lasting. So having an air barrier that's made out of that, when we understand how critical it is to the long-term success of a building staying thermally efficient and reducing those heating and cooling costs, that makes sense that we would want to wrap our building in that. It's also been known to kind of use for those fast track projects because it's less mils thick that you need in order for it to perform the way it needs to. So it goes on quickly with that one coat that dries fast. And it's NFPA 285 exempt. Now, what does that mean? I'm not going to claim to be an NFPA 285 expert, but I'll tell you this. When it comes to the water resistive barriers portion of exemptions, it meets the number one, the peak heat release of that material, the total heat release, the effective heat of combustion. That part is what silicone allows you to use as an exemption for NFPA 285 triggering of projects. And so that might be a little tool to tuck away into your box of tricks that if I'm running into problems with NFPA 285 for whatever reason, what would that potentially moving to silicone do for you? Does it open up more doors? Does it solve a problem? That's what we're looking at here and just giving you some different tools for your toolbox. Because when it comes to vapor barriers and vapor permeability, I think we've heard a lot of times where I can't use a vapor permeable material, so I can't even use silicone because everything I do is vapor barriers. And here's what we know to be true. You've seen this probably everywhere from the Air Barrier Association, that we are way more concerned with air leakage for moisture than we are about the rate of diffusion through the material itself. However, there's been studies that have said vapor flow can be controlled in all climates and all walls and wherever you're at, and all humidity and temperature, all of that can be done. But you've got to follow the rules, right? So, but we do know high performance walls are dry. The higher the moisture level, the higher the heat loss. So we've got to have that ability for the walls to dry out. Faster they can dry out, the more energy efficient they are. And we're thinking about breaking down those thought processes where we learned that we had to choose an air barrier based on where we were located. Now we can look at it and say, it depends on how I'm putting my walls together. Everything works. I can have something vapor permeable if that's really how I'm going to achieve high performance, but I've got to think about all the materials from the outside cladding all the way into the interior of, you know, wallpaper or paint, or what am I using there, so we're not trapping something somewhere. So you're definitely going to look at things. There's definitely always an it depends on what you can do and when you can do it. But it's been proven that high and low permeance barriers can work in all climates. You're just thinking about the entire wall. You're thinking about a lot of things, which is why there's so many consultants out there that we are working with, just to make sure that we've thought through everything, that we're not going to get hit with anything that's going to cause us problems in the end. So there you go. You made it to the summary. If increasing that thermal efficiency in Rainscreen, Assemblies goes beyond adding extra amounts of insulation. Everything is taken into account with penetrations and how those individual components come together, and creating the system out of bits and pieces to figure out something that's going to be able to drain and dry, so you keep something thermally efficient. All right. Did we lose anyone? What do you think, Bo?
All right, awesome. So quick reminder to please submit any questions to the Q&A. You can also raise your hand and I will go ahead and unmute you. You don't have to put your video on, so I promise it's not super scary. If you do want to ask a question that way, it can be easier to ask a more long form question. Let's see, we've got one in the Q&A so far. Someone asking if it's possible to get a copy of the slide presentation. Is that
Yeah,
possible?
if they want to connect with me, I'm happy to send it over. Not a problem.
Okay. Perfect. So I dropped a link into the chat for the place on Acelab where you can get in touch with Linda directly. So feel free to bookmark that link and head over there. You can start a conversation with Linda and ask for those slides. I'm also going to share a link to where we post all of our webinar recordings. So if you want to go back and, you know, not only watch the slides, but get to hear all of Linda's amazing insights, you can go back and watch a recording of this webinar. It usually takes us a few days to get that posted, but we do post all of the recordings of the webinars that we host on Acelab. So one moment, I'm pulling up that link for you guys. All right, I'm gonna drop it in the chat here. Perfect. So if you head over to that articles page, there's a section for webinars, and we've got recordings of all of our webinars over there. All right, awesome. Looks like that was the only question today, which seems crazy. So I'm going to give everyone a few more minutes to, if you have any follow-up questions, feel free to let us know. There's also going to be an opportunity when you leave today's webinar on the post-event survey, where you can ask any questions if you don't think of them right now, but if they come up later on.
I'm going to hope that means I explained it so well there's no questions. Not that there's no interest. No.
I think that must be what it means. We're getting some thank yous in the Q&A chat. So it sounds like, yeah, folks are happy with the information. Doug says you did. All right. Well, in
Perfect.
case any questions come up, we'll hang on here for another moment or so. And I'm going to do a quick refresher for anyone who might not have made it during the beginning of today's webinar, and show you guys how to find Homan & Bernard's products on Acelab, save those over to your account so you can save them to your projects and to your firm libraries. And if you have any questions while I go through this, feel free to post them in the Q&A and I'll keep my eye on that as well. But in case you missed this at the beginning, a quick refresher. So everyone who signed up for today's webinar automatically has a free Acelab account made for them as well. So you can head to acelabusa.com, explore all of the great resources we have over here. And if you would like to just go and get in touch with Linda from Homan & Bernard, you can use the search bar at the top, type in the name of any manufacturer, product category. It cross searches across categories, resources, brands. So sometimes you just got to make sure you're in the right section there, but it should auto-populate once you keep typing in the name. And then if you head over to this page, you can use this contact button, get in touch with their team directly. You can also scroll down here. You can save any of these products to your general research folder, to any project-specific folders. You can also set up your firm's library on Acelab so you can kind of keep all of your standards organized in one place. So this is a great place to come after today's webinar if you want to explore some more information about these products. We've got a lot of great information up on Acelab. You can download, product literature and files directly from here as well. Explore some case studies. You can also come over here and look at some of Linda's past presentations with us. These are some short clips of just some kind of like key moments. So these are great ways to, just be able to get some kind of like high level overview and information. So definitely encourage you to check these out as well. And then we've got some inspiration photos too. So this is a great resource for everyone who's looking to learn some more today about Homan & Bernard's products, as well as get in touch with their team directly. And if you hit that contact button, that is going to create a conversation for you over in your workspace. So this is kind of your space to organize all of the product research that you're doing. You can save projects, you can save products, and you can also have conversations with reps directly in the platform. So this is a really great way to kind of keep all of your research and your communication in one place. And we also actually recently launched the ability to reply by email. So you can, jump into Acelab, you can respond directly in this chat, but you'll also get an email notification anytime you have a new message, and you can reply directly to that email as well. So that really speeds up communication, keeps everything simple. That response will auto-populate in your Acelab account too. So it's super helpful for just kind of streamlining your communication, and, making sure everything is in one place where you can easily access it among other, product information. All right. And if anybody has questions about that, feel free to get in touch with Acelab after today's event. I know Helen also demoed the live chat portion at the top of today's webinar. So you'll see that when you head over to Acelab, there's a live chat box that's staffed by our team, not by any bots. So you'll get in touch with a real person by using that live chat, and we're happy to help out with any questions you might have. All right. Awesome. Well, it looks like we've got a bunch of thank yous. So thank you so much for everyone who attended today. Also, a few more people who are looking for a copy of the presentation. So yeah, feel free to head over to Acelab and start a message with the Homan & Bernard team. They can get you that information as well. And then Kenneth, I see you are looking like you need some support from Acelab's team. So I will make a note of that, and we'll have Helen reach out to you after today's webinar so we can get you all set up. All right, awesome. Well, thank you so much, Linda, for presenting today. Really appreciate it. It's always a really great presentation with you. And I think the fact that we don't have any questions and we just see a bunch of thank yous means you did a really excellent job. So really appreciate it. And everyone, please feel free to give some feedback on that survey when we end today's webinar. That's super helpful for us to be able to answer any questions that you might have, as well as just find out if this content was relevant for you. So we would really appreciate any responses you can give us there. All right. Well, I'll let everyone go a few minutes early. Thanks again, Linda, and thank you everyone else in the audience.
Thanks, Bo. See you later.